Hi, welcome back to our class. Today we will talk about two ways we can classify the cloud. The first one is the deployment classification. The other one is service model classification. When it comes to different types of cloud computing models, the first distinction we can make is between public, private, and hybrid clouds. Each model provides different level of control, security, and flexibility, depending on your needs. Public clouds are owned and operated by third-party providers that offer computing resources over the internet, like storage and processing power. Users rent a part of the infrastructure for their needs. Private clouds are dedicated to a single organization or to selected users. They offer greater control, security, and customization through company firewalls and self-hosting. Hybrid clouds combine elements of both public and private cloud, allowing data and applications to be shared between these two elements. These cloud computing models give companies the ability to achieve the right balance between cost, control, and scalability based on their specific requirements. The service model classification is based on the kind of service the cloud provides. There are three main types of cloud computing models, each offering different level of control and flexibility. Here's a first look at them, listed from the one with the most control over the infrastructure to the one with the highest level of abstraction for the user. First, we have infrastructure as a service, which allows users to get access to virtualized computing resources like servers, storage, and networking services, but they still need to manage themselves the virtual machines and network configurations. In other words, you're just renting the hardware, so you have to handle the setup and the maintenance of your applications. Some well-known infrastructure as a service providers include Amazon Web Services, Microsoft Azure, and Google Cloud. The main advantages of infrastructure as a service are flexibility and scalability, meaning you only pay for what you use and you can scale resources up or down based on demand, which keeps costs low. Next, we have platform as a service that offers not just the infrastructure, but also a platform with tools for developing, testing, and deploying applications. With this model, you still have the flexibility to manage your applications, but you don't need to worry about the underlying operating system, storage, or hardware. This service is used by developers to simplify the process of coding and launching applications. Popular platform as a service providers include Microsoft Azure App Services and Google App Engine. This model accelerates the process of building applications by allowing developers to focus on the code, without needing to manage the underlying infrastructure. The third model is software as a service, which abstracts things even further by offering full functional software applications hosted on the cloud. Users can access software over the internet via web browser without installing or maintaining anything on local devices. These applications are typically subscription-based, and you can scale your usage based on your needs. Common examples of software as a service include Google Workspace and Microsoft Office. The biggest advantage is that this type of service takes care of everything for you. Installations, updates, and maintenance are handled automatically, and you can access the software from anywhere. In summary, as you move from infrastructure as a service to software as a service, you abstract the technical complexity and the infrastructure you have to manage, allowing to focus on higher-level tasks like application development. Each step provides a greater level of convenience but less control over the underlying infrastructure. Cloud computing offers significant advantages that have contributed to its adoption among various industries. These benefits include the cost efficiency, since users only pay for what they use and there are no ongoing maintenance costs, the scalability and flexibility. Cloud Platform offers the possibility to scale resources up or down quickly, allowing companies to accommodate spikes in demand or adjust periods of lower activity. Then we have disaster recovery and backup. Cloud providers often offer disaster recovery services to ensure that the data is backed up and can be restored in the event of a system failure or data loss. Collaboration and remote work, since cloud computing enables teams to work together from different locations. With cloud-based tools, employees can access shared files, applications, and resources in real time, improving communication and productivity features. Automatic software updates. Since cloud service providers handle the maintenance and updating of software, ensuring that users always have access to the latest version without needing to manually upgrade their system, you don't have to do it yourself. While cloud computing offers many advantages, there are challenges that organizations must consider when adopting these solutions. First of all, storing sensitive data in the cloud could raise concerns about data privacy, unauthorized access, and data breaches. To avoid that, it's important to implement strong security protocols and follow them. In the second place, cloud services are not immune to failures, so companies must assess the reliability of the provider they choose and may want to implement backup plans to ensure continuity during downtimes. Last but not least, organizations might face challenges when attempting to migrate to a different provider. Data migration and service integration with another cloud provider can be time-consuming and complex, and buyout fees can be very high. To conclude, cloud computing has changed the IT landscape by providing companies and single users a scalable, flexible, and cost-effective way to access computing resources. From basic infrastructure to full applications, the cloud has transformed the way we store data, run software, and build applications. Understanding the different types of cloud computing models and the underlying technologies such as virtualization, resource management, and security is essential for anyone working in the tech industry today. Despite some challenges, the benefit of cloud computing make it a viable option of companies of all sizes. As technology continues to evolve, the role of cloud computing will only become more central in shaping the future of IT infrastructure and services. Thank you for following this lesson. See you in the next one.